Hi guys, so today we are going to be starting chapter 8, going over similar polygons. For the most part, it's pretty easy, but it's getting all of these little concepts, making sure you're putting stuff in the right places that can be a little tricky. So, corresponding parts of similar polygons. So, a similarity transformation preserves angle measure. So, when we are looking at similar triangles, the side lengths may be different, but the angle measures are congruent still. So, we went over this in a previous chapter with kind of congruency statements, kind of the same concept as far as angles go, but the side lengths are just similar. So, they have a similar ratio. So, in looking at similarity statements, we have this diagram and they tell us triangle RST is similar to triangle XYZ. That little squiggle between is the similarity symbol. And they want us to find the scale factor from RST to XYZ. Now, this is where it is a little tricky because we read this as, okay, well, we're going from RST to XYZ, so we need to put RST first. However, when we're looking at our scale factor, that's not how we do this. You will always put your second triangle shape, you will always put that first. Okay, so when making our scale factor, we want to compare all of our sides. So triangle RST, triangle XYZ, remember in a previous chapter we talked about same position, that those are the ones that are congruent or they are the same. So we are going to work from our small triangle to our big triangle because in this statement here, XYZ came second, so that is what we are going to put on top of our similarity statement. So I'm just going to start at the beginning. So XY is similar to RS. So I just pulled that from our statement over here. XY was the first two terms, RS was the first two terms. So then we are going to put what those lengths were. So XY was 12 and RS was 20. And then we always want to reduce our fractions. 12 over 20 reduces to 3 over 5. We have to do this for every single side of our triangle. So I'm just going to look at the similarity statement that they gave us and just kind of continue. So now I'm going to do side YZ to side ST. YZ is 18, ST is 30. Again, always simplify your fraction. In this case, 6 goes into 18 and 30, goes into 18 3 times, goes into 30 5 times. And our last side would be ZX to TR. ZX is 15. TR is 25. Oh, sorry about that. 5 goes into 15 3 times, and 5 goes into 25 5 times. So this is what you are hoping for whenever you do these similarity statements. Your ratio should be the same for every single side that you have. So that's kind of the whole point of figuring out your scale factor. This is also why it's important to make sure that you do your scale factor correctly by always putting that second statement, that second shape, whatever it may be, is always the top of your ratio, and the first is always the bottom. Part B asks us to list all pairs of congruent angles. So really, you can just take this again from the similarity statement that they gave us because everything is in order. So angle R is congruent to angle X. They're both in the first position. Angle S is congruent to angle Y. They're both in the second position. And last, angle T is congruent to angle Z. They're both in the last position. Those, you could have also flipped those around. You could have done X is congruent to R, Y is congruent to S, Z is congruent to T. Totally fine. Just make sure that you keep it the same. So if you were going from the first triangle to the second triangle, keep that the same for all of your congruency statements. If you're going from the second to the first, again, keep it the same for all of your statements. And then for part C, it says to write the ratios of the corresponding side lengths in a statement of proportionality. So we've already found our ratios. We did that in part A. So what it wants now is it doesn't want numbers, it just wants the letters. So this is really what we did from the first part. Now they just want us to write it all out in words. So we did XY to RS first. That was just the first side we picked. Doesn't matter which side we picked first. But then we found out that that was equal to YZ over ST because they both had the same measurement, which was equal to ZX over TR. So this is a statement of proportionality. It just pulls all of those sides together and says, okay, from the second triangle to the first triangle, this side went with this side went with this side, so on and so forth. And that common ratio between all of those pieces was 3/5. That is all this is saying. All right, so we have another one. So we will go through another example. It tells us in the diagram, triangle JKL is similar to triangle PQR. And they want us to find the scale factor from JKL to PQR. So remember, whatever is second is going to go on top of our fraction. So in finding our scale factor, we're going to do PQ over JK. I just always start at the beginning of my statement, so I just picked PQ to start with. PQ was 9, and JK was 6. 3 goes into 9 3 times, and 3 goes into 6 twice. Next, I will do QR to KL. QR was 6, KL was 4. 2 goes into 6 3 times and into 4 twice. So already looking good here. We have the same scale factor for these two. So then for our last one, we do RP to LJ. RP is 12 and LJ is 8. 4 goes into 12 3 times and into 8 twice. So just like we want to happen, all 3 of our sides have the same scale factor. If you go through this and you do not get the same scale factor, make sure that you're putting numbers in correctly, putting the second image or shape on top of the first, and just pulling the right numbers over. Listing the congruent angles, again, remember, just pull that straight from the similarity statement. So your first position is congruent to your first position and your second. Second position goes with second, and third goes with third. So hopefully some of this at least seems slightly familiar because we did cover it with our triangles. I think that was 2 chapters ago, as far as the congruency statements, finding the common sides, all that stuff. So hopefully that part kind of seems a little familiar. And then the last thing, writing that statement of proportionality, is really just pulling down all of those pieces from part A. And it does not matter the order that you put these in because they all equal the same thing. And that was 3/2. So you could absolutely put QR over KL equals PQ over JK equals RP over LJ. It does not matter that order. It is just putting out all of the statements that all of these sides equal all of these sides, and this is their proportionality, their scale factor ratio that they come out to be. All right, so next we go to corresponding lengths in similar polygons. So this is kind of how those ratios can be used to help us find missing side pieces. And it states if two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. So for number one, I feel like it just makes more sense to actually work through a problem. Sometimes those definitions just get a little wordy. It says in the diagram, triangle DEF is similar to triangle MNP. Find the value of X. So keeping in mind the process that we just did of making those scale factors, putting this side with this side gives us the scale factor, and so on and so forth. So I'm going to keep up with the concept of always put your second shape on top of your fraction for your ratio. And it does not matter necessarily what side you pick. However, you need to include this similar side. You have to find X. So when setting up your ratios, you have to include that side. So for sure, we need to include side NP from triangle 2 because that is similar with side EF in triangle 1. I'm going to label these just to notate which triangle I'm referring to. Okay, so we have those sides have to be proportional. They will give us a scale factor. Well, now we just have to pick one other pair of sides to use. We could use MN and DE, or we could use MP and DF. So doesn't matter which one. I'm going to use MN and DE. So MN over DE. So remember, all of our sides are going to have the same proportion. They're all going to have that same fraction statement, which is why we can say NP over EF equals MN over DE, because they're going to equal the same ratio. So now we are going to plug in the information. So NP was 30. EF was X. We didn't know what that was. MN was 18. And DE was 15. At this point, we cross multiply, which again, hopefully seems a little familiar. Let's see, we have 18 times X, which is just 18X. And then 30 times 15, which gives us 450. So then to solve for X, we just divide both sides by 18. And we get X to equal 25. And that is all we had to do there. We just had to solve for that missing side. So then in number 2, we have the same idea, except now for once we don't have a triangle. We actually have a quadrilateral to deal with. So it doesn't tell us a similarity statement, but based off of the shape and the way it's laying, we can kind of figure out what is what here. So I'm going to say quadrilateral 1, quadrilateral 2. And we need to solve for X. So we have to include that side when making our proportions. So from our shape 2, RS lines up with BC. We're just going to base it off of they're in the same position, so those are the ones that we're going to say are proportional. And then we just pick two other sides that are in the same space. So you could do AB and QR, DC and TS, DA and QT. I'm just going to pick DC and TS. So TS was my shape 2, so that goes on top. DC was my shape 1, so that goes on bottom. So then now I just plug in my stuff. So RS was 4. BC was our X, that's what we don't know. TS is 8. And, oh my goodness, I'm so sorry. And DC is 16. So again, at this point, we do our cross multiply. 8 times X is just 8X. 4 times 16 is 64. And last, we just divide both sides by 8. And we get that X is 8. So these proportion statements, it's like I said, you just pick any side that you want, line those up, set them equal to whatever side you're missing. The side you're missing has to be included in your proportion. And then outside of that, just make sure your other two sides are actually in the similar positions. Usually you will be given this statement. I apologize that in problem 2, they didn't actually give you that statement, but we were able to kind of determine what side matched up with what because of that slanted side. All right, finding a corresponding length. This one is a little tricky. So it says in the diagram, triangle TPR is similar to triangle XPZ. Find the length of the altitude PS. So it is looking for this guy right here. And the only thing that we know is TS and SR, and then XY and YZ. And then we know that PY is 20. So keep in mind that these two triangles have to be similar, right? So they have to have the same ratio. But it is the whole triangle, not these little triangles that they're split up into. The whole triangles are proportional. So let's look at this. Our second triangle was the XPZ. So this whole length here is one side of that triangle. So that whole side there is XZ. And then this whole side here would be TR. So those are proportional. They're in the same position. So XZ is going to be that whole side. So that's going to be 8 plus 8. And then TR is going to be 6 plus 6. So we have to add those two pieces together to get that full side length. So that gives us 16 over 12. Remember, always simplify your fractions because it's just going to make life a lot easier. So 4 goes into 16 4 times, and it goes into 12 3 times. So our scale factor for these triangles is 4/3. So now, when we are looking at the altitude pieces, they are going to have the same scale factor. So this PY and PS, they will have the same scale factor of 4/3 that we just found. So, again, we will go from our second triangle to our first triangle because that's how we did it here. And you need to keep everything, again, proportion. Make sure you keep your stuff in the same spaces. So PY to PS. So big triangle to small triangle, triangle 2 to triangle 1, has to be equal to 4/3 because that was the scale factor that we just found. We know that PY is 20, and we're going to say PS is X just because it's a little bit easier to deal with than 2 letters. And now this looks just like what we just did above, where we have to cross multiply to solve for that missing side. 4 times X, it's just 4X. 20 times 3 is 60. Divide both sides by 4. And we get X to equal 15. So to rewrite that in answering the problem, PS is 15. So again, be cautious. This 4/3, remember, we used the XPZ triangle over the TPR triangle. So when we came down here, we had to make sure to keep it the same. We had to use the XPZ triangle up top and the TPR triangle on the bottom. If you flipped those, then it could mess up your answer. So the last 2 things that we have to cover are perimeter and area of similar polygons. These can get even trickier because it's kind of like a formula you have to remember a little bit on the way that needs to be set up. So for perimeter, it says if 2 polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So the ratio of the perimeters is equal to the ratio of their sides. So for this first example, it says the 2 gazebos shown are similar polygons. Find the perimeter of gazebo A. Very first thing you need to do is find the perimeter of gazebo B. So for perimeter, remember that is just adding up all of your sides. So for gazebo B, you would add 15, 9, 12, 15, and 18. And that would give you a perimeter of 69. Okay, so the ratio of the perimeters is equal to the ratio of their corresponding side lengths. For gazebo A, we only know this side. Everything else is unknown. But AB and FG are in the same position, so they have to be similar. So we put gazebo B of 15 over gazebo A of 10. So that is the side lengths. And then that is equal to the perimeter of gazebo B over the perimeter of gazebo A. So before I get started here, before I start actually doing the cross multiplying and all that, this 15 over 10 can absolutely be simplified. And so I'm going to do that just to make my life a little bit easier to have smaller numbers to deal with. So 15 over 10 simplifies to 3 over 2. And now I can cross multiply. 3 times x is just 3x. And 69 times 2 is 138. And last step, we just divide both sides by 3. And we get x equals 46. So perimeter of gazebo A, perimeter of A is 46 meters. So instead of having to go through, find every single side for gazebo A, we're able to use this formula of the side lengths ratio, so the same proportionality we've been working through this whole time, is equal to the perimeter of your second shape over the perimeter of your first shape. And so we'll have another example of working through that with one a little bit easier because we're dealing with a rectangle at this point, but still the same concept. So it says a town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. The new pool will be similar in shape to the Olympic pool, but will have a length of 40 meters. Find the perimeters of an Olympic pool and the new pool. So I'm going to draw two pictures to help me out. So we have the Olympic pool, which has a length of 50 and a width of 25. And then we have the new pool, which has a length of 40, but we don't know the width. So with this being a rectangle, we know that opposite sides have to be the same length. So in an Olympic pool, this side has to be 50 and this side has to be 25. So the perimeter of the Olympic pool, of Olympic, is going to be 150 meters, right? Because 50 plus 50 is 100, 25 plus 25 is 50. Add those together, we get 150. So now we need to find the perimeter of this new pool. Well, we can do the perimeter, or no, I'm sorry, not the perimeter, the ratio of our side lengths. So from the, I'm going to say the Olympic pool is our number 2, just because it's bigger, but it doesn't necessarily matter which way we do it. So we know that the lengths are proportioned, right? So the length of the Olympic was 50 and the length of the new is 40. And then the perimeter of the Olympic is 150, and then we don't know the perimeter of the new. And again, now this just looks like all of the other ones that we've done. We cross multiply. 50 times x is just 50x. And 150 times 40. I definitely should have simplified my ratio like I said to do before, but I didn't think about it. Is 6,000. And divide both sides by 50. And we get 120. So you still get the same answer even if you don't simplify your ratio, but simplifying your ratio will make for way smaller numbers. So if we would have simplified that 50 over 40 to 5 over 4, it would have just made it a little bit smaller to deal with, but you still get the same answer. So the perimeter of new is 120 meters. So remember, when dealing with perimeter, you still have to set up a side ratio. The two sides that you know are similar, they're in the same position. And then you set it equal to perimeter of what you know over perimeter of what you don't know. And then last but not least, we have areas of similar polygons. So kind of similar to perimeter. It says if two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. So with perimeter, you still had to have the ratio of your sides. and then it was just equal to perimeter over perimeter. Now you have area over area equal to the ratio of your sides, but you have to square those sides. So I'm going to do my best to explain this. Let's see. Let's say side B over side A squared equals area of B over area of A. Okay, so in the diagram, triangle ABC is similar to triangle DEF. Find the area of DEF. So we have our two shapes. We only know one side for each triangle, so those have to be the similar sides. So again, shape 1, shape 2. So I'm going to put 5 over 10. Those are just the similar sides that we have. And that has to be squared. And that is equal to the area of DEF, because that was the side that we put on top first, which we don't know. We don't know what the area of DEF is, over the area of ABC, which they tell us down here, the area of ABC is 36. So before we can cross multiply, we have to get rid of this square. So we have 5/10 squared. So that means you just do 5 times 5 up top, and then 10 times 10 on the bottom. So that gives us 25 over 100. Again, you can simplify that ratio, or you can just leave it alone. So we get 25 over 100 equals x over 360. So now we get to the point where we can cross multiply. 100 times x is just 100x. And then 25 times 36 is 900. And divide both sides by 100. You get x equals 9. So that means that the area of DEF is 9 centimeters squared. Area, your measurement is always squared. But I think this little formula here will be kind of helpful in how to set up the problem, I hope. And then actually, I'm going to go up here. I'm going to backtrack a little. I apologize. So for polygons, I'm going to say, or a perimeter, I'm sorry, side B over side A, if I could write, equals perimeter B over perimeter A. Those are kind of helpful equations to be able to see it, hopefully, so when you're looking through these examples later, you can see where everything kind of comes from. And on this last one, I'm not sure what happened, but the information got cut off. So we know that the area of GHJK is 84 meters squared. That was supposed to have been given to you, but like I said, for some reason it got cut off. Okay, so in the diagram, GHJK is similar to LMNP. Find the area of LMNP. So 1 and 2, we only have the one side that they gave us, so that means we put that side over the side of the first and square it. And it is equal to the area of the second, which we did not know, over the area of the first, which is 84. Remember, you just need to make sure you keep your stuff in line. So if you put the second shape first, if that's on top, then after your equal sign, keep the second shape on top. We first have to simplify that square. So we have to do 21 squared. So 21 times 21 gives us 441. Again, this is probably a good spot to have simplified first, but I did not. And then 7 squared, 7 times 7 is 49. And then equals x over 84. So then we do our cross multiply. Oops. 49 times x, that's just 49x. 441 times 84 is 37,044. Like I said, a good spot that simplifying that ratio might have been beneficial. And divide both sides by 49, we get x to equal 756. And we'll just say meters squared. And our fun little meme to end the day. All right, and that wraps up the notes for today.